In this video, I'm going to be deriving the unit circle for you. On this first page, you can see that I have the entire unit circle blank. The first thing that we're going to go through is the degrees. The second thing we're going to go through are the radian values all the way around the unit circle. And then finally, we're going to look at the coordinates on our unit circle. All right, so keep in mind that, again, our unit circle has a radius 1. So this first point right here is going to be our starting point at the point 1, 0. That's also going to be our first degree measure, our degree 0, before we start rotating around the unit circle. So the first thing that I'm going to do is I'm going to do our first value, 90 degrees. So I'm going to skip up here to 90 degrees. And as you can see, this is a quarter. It's 1/4 of our unit circle. And I'm sure, as you all know, when I go halfway around my circle, I create a straight line, which gives me 180 degrees. Again, I have another right angle here, so I have 180 degrees plus 90 degrees gets me to 270 degrees. And then a full rotation around the entire unit circle is 360 degrees. So if you can see kind of this second line right here, it splits this 90-degree measure in half. So if I'm splitting 90 degrees in half, that makes that 45 degrees. And as you can see, I'm an equal distance away from 45 degrees, both in the positive direction and in the negative direction. And so basically what that tells me is that I'm going to go 15 degrees in both directions. So if I add 15 degrees to 45, I get 60, and if I subtract 15 degrees, I get 30 degrees. So if you can see, we kind of get this pattern going. So to my first line, I added 30 degrees. To get to my second line, I added 15 degrees. To get to my third line, I added again 15 degrees. And to get to 90 degrees, I added 30 degrees. So we're going to basically use this pattern of increased rotation to be able to fill in all the degree measures around the unit circle. So if I'm at 90 degrees, I need to add 30 degrees, and that gets me to 120 degrees. Then I add 15 degrees, and that gets me to 135 degrees. Again, adding 15 degrees, I get 150 degrees. From 150, I should add 30 degrees, which indeed does get me to 180 degrees. From 180 degrees, I again want to add 30 degrees, which gets me to 210 degrees. I then want to add 15 degrees, and I get 225. Adding 15 again gets me 240 degrees. Adding 30 degrees better get me 270, which it does. Adding 30 degrees again, I get 300 degrees. Then adding 15 degrees, I get 315. Adding another 15 degrees, I get 330. And adding 30 degrees does get me back to 360 degrees. So you can see how starting at 0 degrees and rotating along 30 degrees, 15, 15, and 30 degrees, I can use that symmetry to get me all the way around the unit circle in degree measures. Okay, so for radian degrees, if you remember in the converting between degrees and radians video, we use the conversion factor of pi radians over 180 degrees. So I can actually use that conversion factor on all of the degree measures that I now have in order to obtain the radians. So here my degrees would cancel, and I would have 30 divided by 180, which gets me pi over 6. For 45 degrees, again using the same conversion, I would have 45 divided by 180, which gets me pi over 4. So again, using this conversion factor, I would have 60 degrees times pi radians over 180 degrees. My degrees will cancel, so I have 60 divided by 180, which gives me pi over 3 radians. For 90 degrees, we talked about this in the radian video, that I'm basically rotating a quarter of the way around the unit circle. So again, in that video, we said 1/4 of a full rotation, which is 2 pi, gives me that pi over 2. So for 90 degrees, my radian measure is pi over 2. Now I'm going to try and color coordinate all of my radian values here so you can kind of see the connection. So as we keep rotating around, basically in the second quadrant, this pi over 3 basically gets kind of reflected across the y-axis, and I can just simply subtract 1 from the denominator in order to get my numerator. This is just a trick that I use in order to help myself remember what the radian measures are correlating to a specific degree. But again, you can still use that pi radians over 180 degrees on every single one of your degree measures to obtain the radians. So for my 45 degree, I have 4, subtracting 1, I get 3 pi. So I have 3 pi over 4 for 135 degrees. For 150 degrees, I would get 5 pi over 6. For 180 degrees, again, we talked about that in the radians video. I'm rotating halfway around my unit circle, so half of 2 pi is pi. Then again, here we have this 5 pi over 6. It's going to get reflected across the x-axis now. So my little trick for the third quadrant is you simply add 1 from the denominator and put it on your numerator. So here I would have 7 pi over 6, which correlates to 210 degrees. For 225 degrees, I would have 5 pi over 4. And for 240, that would be 4 pi over 3. Again, talking about this rotation to get down to 270 degrees, we have traveled 75% around that unit circle. So that's going to give me 3 pi over 2. And now I have this 4 pi over 3 gets reflected across the y-axis again. And my little trick for the fourth quadrant is to multiply the denominator by 2, which in this case would give me 6, and then subtract 1. So for 300 degrees, I get 5 pi over 3. For 315 degrees, I get 7 pi over 4. And for 330 degrees, I get 11 pi over 6. Again, you can see now kind of more clearly why I wanted to color code this. So if you look here, the reds, all of my radians that have a 6 in the denominator kind of make this crossing action here. And then the radians with the denominator of 4 cross here. And then the radians with the denominator 6 all cross here. So you can really see how they're pretty much being reflected across the y-axis and then reflected across the x-axis. So they all have this relationship to one another. And you'll really be able to see that once we start talking about the coordinates on this slide. So if you remember back to the video with triangles in trigonometry, I talked about the isosceles right triangle, how it has two equal sides and two sides of equal length, and how when we had an isosceles right triangle, our two angles of equal length were both 45 degrees. And we were able to set our two sides of equal length to 1, which allowed us to be able to solve for the hypotenuse and get the square root of 2. That then allowed us to be able to find the sine of 45 degrees and the cosine of 45 degrees. So when we're talking about the coordinates on our unit circle, here is my 45 degrees. The cosine of 45 degrees is my x term. So basically, I'm going to drop my perpendicular line to the x-axis to form my reference triangle. And my x distance, which correlates to this point, is the cosine of 45 degrees, which we found to be square root 2 over 2. And then my y distance is going to correlate to the sine of 45 degrees, which we also found to be square root 2 over 2. So as I said, all of the radians that have a denominator of 4, they're all increments of quarter rotations around the unit circle. So each one of these is going to have the same square root 2 over 2, square root 2 over 2 for both x and y coordinates, but what's going to change is going to be the sign. So in the first quadrant, both x and y are positive. In the second quadrant, my x is negative and my y is positive. So whenever I go to do the coordinates for 135 degrees, I will have negative root 2 over 2 and then a positive root 2 over 2. In the third quadrant, both x and y are negative. So 225 degrees will have coordinates negative root 2 over 2, negative root 2 over 2. And then 315 degrees, in the fourth quadrant, we have a positive x and a negative y. So I'll have positive root 2 over 2 and then a negative root 2 over 2 for my coordinates. So now if we look at 30 degrees, again going back to that triangles and trigonometry video, we talked about an equilateral triangle and how an equilateral triangle has a 30-degree angle, a 60-degree angle, and a 90-degree angle, and we were able to use an equilateral triangle in order to be able to find all three sides of our right triangle. And then we said that the sine of 30 degrees is 1/2 and the cosine of 30 degrees is root 3 over 2. So if we're looking over here, cosine of 30 degrees is root 3 over 2 and the sine of 30 degrees is 1/2. So again, now any radian that has a 6 as its denominator is going to have these coordinates, and the sine is going to be the only thing that's going to change. So going into the second quadrant, we have 150 degrees. So my x is going to be negative root 3 over 2, and my y value is a positive 1/2. Then we have 210 degrees. Both x and y are negative in the third quadrant. So I have negative root 3 over 2 comma negative 1/2. Then I have 330 degrees. I have a positive x value, root 3 over 2, and a negative y value, so a negative 1/2 there. All right, then again, one last time, going back to our triangles and trigonometry video, we also found that the sine of 60 degrees was root 3 over 2, and the cosine of 60 degrees was 1/2. So the cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. So again, any radian value with a 3 in the denominator is going to get these coordinates, again just changing the sign. So here we have 120. My x in the second quadrant is negative, so I have negative 1/2, positive root 3 over 2. For 240 degrees, I have negative 1/2, and a negative root 3 over 2. For 300 degrees, in the fourth quadrant, my x is positive, so I have a positive 1/2 and then a negative root 3 over 2. So now we pretty much have everything filled in except for our 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Well, I saved the easiest for last because, again, this is a radius of 1, so that means I've traveled a distance of 1 in the x direction and 0 in the y direction. For 90 degrees, I've traveled 0 in the x direction and a positive 1 in the y direction. For 180, a negative 1 in the x direction, a 0 in the y direction. And for 270, 0 in the x direction, and a negative 1 in the y direction. And so now we have completely filled our unit circle. We've talked about the degrees, we've talked about radians, and we've talked about all of the coordinates. I would highly suggest that now you've learned about the unit circle that you print off a completed unit circle and just have it with you while you're working on your homework because it makes things just that much easier.